Hey everyone, and welcome to our explainer. Today, we're diving into a book that really changed how we all look up at the night sky. It's a book that asked the biggest questions you can possibly imagine and tried to answer them for every single one of us.
I mean, think about it. Where did all of this come from? It's probably the most profound question we can ask, and it's the exact question the legendary physicist Stephen Hawking decided to tackle in his 1988 masterpiece, not just for other physicists, but for you and me.
So what made this book such a game changer? It wasn't just what Hawking was talking about, it was how he was talking about it. His big idea was to tear down the walls and make science something anyone could get excited about.
Hawking's mission here was, frankly, amazing. He wanted to take the most complex, brain-bending ideas in all of cosmology, the literal rules of our existence, and just explain them, using simple language, clever analogies, everyday examples. The whole goal was to let any curious person in on the universe's biggest secrets, no PhD required.
So, with that mission in mind, the book takes us on this wild ride, and it starts with the very fabric of our reality itself, something called space-time. The book throws us all the way back to the beginning. Hawking explains how everything, and I mean everything, you, me, the stars, the whole shebang, it all started as the single, impossibly hot and tiny point. Then, boom, about 13.8 billion years ago, a colossal expansion kicked off, the Big Bang. And as the universe blew up, it also started to cool down, which allowed the first atoms to form. And over millions and billions of years, gravity started doing its thing, pulling all that stuff together to build the incredible stars and galaxies we can see today.
Now, to get your head around this new cosmos, Hawking first has to explain a huge shift in thinking. For the longest time, we thought of space and time as two different things. You know, space was like a big empty stage, and time was like a clock that ticked the same for everyone. But building on Einstein's genius, Hawking shows us how they're actually woven together into one thing, a single four-dimensional fabric called space-time. And get this fabric isn't flat. It gets bent and warped by heavy stuff like planets and stars. That warping is what we feel as gravity. Wild, right?
Okay, now we get to one of the most exciting and, let's be honest, terrifying topics in the whole book, the super strange and powerful world of black holes.
So how do you cook up one of these cosmic monsters? Well, Hawking walks us through it step by step. First, you need a gigantic star, way bigger than our sun. After it burns through all its fuel, it can't fight against its own crushing gravity anymore. The core just collapses in on itself, squeezing down into this point of infinite density. The gravity there becomes so mind-blowingly strong that nothing, not even a beam of light, can get away.
And this is where Stephen Hawking made his own legendary mark on science. He came up with this groundbreaking idea that black holes aren't actually the eternal cosmic prisons we thought they were. Nope. He figured out that thanks to some really weird quantum stuff happening right at their edge, they slowly leak a tiny bit of energy and radiation. We now call it Hawking radiation. And what that means is, over an almost unbelievably long time, a black hole can actually evaporate and just disappear. So they're not forever after all.
This all brings us to the book's biggest dream, the ultimate quest in all of science, the hunt for one single theory that explains absolutely everything.
You see, all of modern physics is basically held up by two incredible yet totally incompatible pillars. On one side, you have Einstein's general relativity. It's perfect for describing the really big stuff, planets, galaxies, how gravity works. On the other side, you have quantum mechanics, which is our amazingly precise theory for the super tiny world of atoms and particles. The problem? They hate each other. They give different answers. You try to use them together, like to describe a black hole, which is both supermassive and super small, and the math just completely falls apart.
And that big conflict is what fires up the biggest hunt in physics, the search for a theory of everything. It really is the Holy Grail, the dream of finding one single, elegant framework that can finally bring relativity and quantum mechanics together and explain all the rules of the universe in one go.
So, all these years later, why is A Brief History of Time still such a huge deal? Why does it keep drawing us in? let's take a quick look at its legacy. The book's greatest strength, for sure, is how it makes these huge ideas feel within reach, how it sparks that sense of wonder in millions of people. But let's be real, it's not always a walk in the park. Some of the chapters, especially when he gets into quantum physics, can be tough for a total beginner. You might have to read a paragraph a few times, and you know what? That's okay. That little bit of a struggle to understand is kind of part of the journey.
But in the end, the book leaves you with this really powerful and honestly humbling feeling. It makes you look up at the night sky and not just see a bunch of lights, but to really feel that you are a part of this vast, intricate, and absolutely beautiful cosmos, and that trying to understand it is one of the greatest adventures we can ever be on. And that's maybe the book's final, most powerful message. The journey of discovery is nowhere near over. It just makes you wonder, what's next? What's the next great cosmic mystery that we have yet to solve? Is it dark matter? Dark energy? Are there other universes out there? What's the next puzzle that the next Stephen Hawking is going to help us all figure out?